Nephrons have three major jobs. Filtration is the first job. To filter the blood happens early on in the glomerulus. The second job is reabsorption. They have to reabsorb so much water in order to maintain blood volume. The third major job is secretion. Secretion is the process by which certain things can be intentionally removed from the blood, blood that didn't perhaps make it through filtration, but blood that's in the peritubular capillaries. Sometimes things need to be removed intentionally from that blood. And there's a way to do that. Substances can be moved from the peritubular capillaries into the tubules, and this is called secretion. So when we talk about like the overall job of the kidneys is to remove things from blood and hold back important substances. Things that are removed, we would say that they are being cleared, right? They have to be cleared from the blood, and they're going to be excreted in the urine. So when we talk about renal clearance, this is referring to the fact that some things are removed from the blood and excreted. Renal clearance is something that differs depending on which stage we're looking at within the nephron. If we're looking just in the glomerulus, the filtrate, there would be a very high renal clearance at that point because reabsorption hasn't taken place yet. As the filtrate moves down the proximal tubule, renal clearance decreases because water is being reabsorbed. As we continue on down into the loop of Henle, that's the area where the peritubular capillaries are kind of wrapped around the loop of Henle, and that's a convenient site for exchange to happen. So that's the site at which secretion is going to take place. So we're going to finish off thinking about the job of a nephron with this topic of secretion. Overall, in terms of what gets removed from the body in the urine, overall the excretion is the to refer to that, what is being removed. Excretion can be thought of as the sum of all of these different processes. So we've got filtration that happens early on, then we have reabsorption, so we're going to go filtration rate minus absorption rate, reabsorption rate, and then we're going to add in plus the secretion rate. And it's the sum of all of those things put together that makes up the overall excretion from the kidney. That excretion rate can be used to estimate the GFR, the glomerular filtration rate, and that again can give an indication of the health of the kidneys. We've talked about reabsorption in the context of water. We need to reabsorb a lot of the water that makes its way into the tubules. There are other substances that get reabsorbed too. Some good examples of that would be amino acids. Amino acids might be small enough to make it through the filtration process, so they end up in the filtrate, but then they will be reabsorbed. We don't want to just be flushing out amino acids with the urine. And then also glucose. Let's look at glucose for a moment. Reabsorption of glucose. This is something that glucose, it's a small enough molecule that it can be passed through with the filtrate in the glomerular capsule. So it ends up in the tubules, and in the proximal tubules, so early on in the nephron, in the proximal tubule, this is where glucose gets reabsorbed. It gets reabsorbed by active transport. It's a co-transport with sodium. So sodium, let's take a look at the picture here. Sodium is shown in purple, glucose is in blue. So as sodium travels down its concentration gradient, that's going to power the transport of glucose into the cell. And then from there, that sodium will be transported back out of the cell, right here with the sodium-potassium pump. So sodium out, potassium comes in. Meanwhile, glucose, over here, glucose will be transported out by a facilitated diffusion. So concentration of glucose will build up inside of this cell, which will mean there will be a concentration gradient driving it to move out of the cell into this space. Okay. And then glucose will diffuse into the peritubular capillaries. There's a limit on how much glucose can be transported. There's a limiting step there with the co-transport of sodium. And if there's too much glucose in the blood, then it might end up that not all of it can be reabsorbed. And so then there would be glucose in the urine. And that can be an indication of diabetes.